Good afternoon.
Good afternoon. Good afternoon. Hope everybody's doing great. All right. All right. Good afternoon. Good afternoon. I hit the wrong button. There we go. All right. Still got some people trying to get in. All right, looks like everybody is in. Okay, so once again, good afternoon. Hope everybody's all right. Hope everybody's doing great. Ready to get the weekend started. So I shot you guys an email asking about class and starting February 1st, what you guys' opinions are. So make sure you email me back with your preference so we can know how to move accordingly. So most everybody did respond, but respond to the email and not right now, so that we can make sure that everybody's accounted for as far as their opinion on class and everything. And so yep. Let's see. I think this, yeah. Oh yeah, I sent you that unit circle. I finally did that not too long ago, right? So for those who were asking about it, you got it now. And I think that's it. So I know we were in 5.7. I'm just taking a look at 5.8. See how much I got in here. Okay. All right, so we're right here in 5.7, the last class. And may just do this 5.7 and do 5.8 next class. But we'll see. We go right here. Okay. So we're looking at inverse properties. Remember last class we were talking about your inverse trig functions. So we had looking at sine inverse, cosine inverse, tan inverse, and how they're used. So now we're looking at the inverse property, actually applying sine to sine inverse and then sine inverse to sine, and how that works for us.
I have a quick question.
Mm-hmm.
What happened to 5.5 and 5.6?
They were just graphing. So I said just go ahead in there and use the graphing tool to answer the questions. But I wasn't going to spend much time on graphing. Now, if somebody had a question, I wasn't willing to answer it, but I wasn't, going to spend much time in graphing. When most of the time when somebody want to graph something, they would just use a graphing calculator or Desmos, some type of graphing tool to do so. So I wasn't going to put much stock in that process. Yeah.
Gotcha. Thank you.
Yeah, no problem. But once again, let me reemphasize, if anybody have any questions on that, feel free to ask, and we'll address them accordingly. So yep. Thank you for asking, just in case somebody else didn't catch that. So now we're here at about to finish off 5.7. So we got sine and sine inverse. So notice the positioning. If you have sine on the outside and sine inverse on the inside, that applies, that will cancel out to just x as long as your domain is -1 to 1. But if you have sine inverse on the outside but sine on the inside, then that's for your domain to be -pi/2 to pi/2. So you do have to watch, what's being plugged in or what's supposed to be x in our case. And you'll see in a second how this is going to work for us. Same thing for cosine. Notice if cosine is on the outside, cosine inverse is on the inside, then it's -1 to 1. But if cosine inverse is on the outside and cosine is on the inside, then you have 0 to pi. Yep, somebody got their hand raised?
Yeah, sorry, I guess I should have asked this before you got started, but I know that the college campus says that it's opening on February 1st. So where are we supposed to go? Like, are you going to have in person? Like,
yeah, did you see the email? Did you see the email I sent?
no, I didn't see it.
Is your classroom in building A 105?
Okay, hold on, sir. Let me answer a question, please. Give me a second. So yeah, so check the email. I sent an email out. It's in also in should be in Canvas announcements. I was asking everybody's preference on what they want to do moving forward when it comes to February 1st, basically what you're asking. Because we can stay virtual, you know, if everybody agrees or whatever. But I need to put that out there first and see what everybody is saying and how everybody feels about it. And so once I get there, keep paying attention to your emails. Probably going to send the email out on probably Sunday evening and let you know how we're going to operate moving forward. So I just need, you know, as many people as possible. Really, I would love everybody to respond to that email, but I need as many people as possible to respond to that email, and then we'll go from there. So most definitely, you should be receiving instructions from me by Sunday evening.
Okay, thank you.
Not a problem. And I believe what your classmate was mentioning is that if we do go strictly back face to face, then our room number is A105. But all of that will be in the email though when I send it out. So yeah. All right. Everybody done with some? All right. And then here's tangent, same type of application. Tan is on the outside, but tan inverse is on the inside. That's for every real number. Tan inverse on the outside and tan is on the inside. Domain is negative pi over 2 to pi over 2. Oh, also notice, did I write that? Okay, that's it. Also notice we have parentheses here, where in the other ones we had brackets. So that means, you know, pi over 2 and negative pi over 2 is not a part of the domain when it comes to this tangent relationship. So make sure you notate. All right, can we scroll up? Is everybody good? Try this out. All right, so directions, find the exact value. If possible, is key there. So this first one, the problem is in black, of course, got answer in red. So we have cosine applied to cosine inverse of 0.6. So now going back to what we just set up, cosine is being applied to cosine inverse. So if x is in between 1 and 1, negative 1 and 1, then our answer will just be whatever it's being applied to by the cosine. In other words, our cosines will cancel. So that's why our answer is just 0.6. All right. So the cosine and cosine inverse cancels, leaving us with just what our x was, which was that 0.6. All right. So the next one's a little tricky, so I want to make sure we're okay with it. Is everybody okay with A before we look at B? All right. So looking at this one right here, we have sine inverse of sine 3 pi over 2. So we have to be careful here because when we have sine inverse on the outside, you know, this is our domain. So we're talking about pi, negative pi over 2 to pi over 2. All right, so when you're talking about pi over 2 to negative pi over 2, trying to use this stuff. So this is negative pi over 2, and this is pi over 2. Now, negative pi over 2 is the same thing as 3 pi, positive 3 pi over 2. So those are the same values you're talking about right here. and that's negative pi over 2, but it's the same thing as 3 pi over 2. All right. And not sure why I put this right here. Let me write this better. All right. So that means that that 3 pi over 2 actually fits in our domain. Oh, I wrote it down right here. Let me figure out why I wrote that right there. Anyway. Oh, okay. I see what I was doing there. That -1. But anyway, next sine inverse of sine negative pi over 2. Since negative pi over 2 is in our domain, it cancels out just like it happened up here. And that leaves us with negative pi over 2. So it's one of those things where we have to look at this 3 pi over 2 and ask ourselves, does it fit in the domain of what's being asked? And because it goes from pi over 2, negative pi over 2 to pi over 2, we do have to consider going in a negative direction. And so going in the negative direction, negative pi over 2 is the same thing as 3 pi over 2. And so that's why it simplifies to just 3 pi over 2. All right, questions on that? I guess I could have updated one. I understand what I was doing there, but it's not necessary. I'll leave that there for right now. But questions on what we did there. And that's what, just another notating that 3 pi over 2, which is negative pi over 2, is in that domain of negative pi over 2 to pi over 2. We'll go to C. All right, so cosine of cosine inverse of 1.5. And they should have some type of answer that you can choose from in math lab, whether it be not defined or no answer or something like that, no solution, something like that, that you can choose whenever there is no answer. 1.5 is outside of this domain of -1 to +1. So it will not work. And some of these you can put in the calculator and it will give you the answer and it'll let you know, but this is the rationale behind it, is because of these domains that we have set up. When you go outside of those domains, then the functions will not work, or the applications will not work. If you were to throw this in the calculator, it would give you some kind of error or something like that. If you were to throw this one in the calculator, it will give you 0.6. Now this one, you have to be careful, because unless you know the decimal value of negative pi over 2, you know, it will give you a run on decimal. And remember, they want the exact answer, exact value. So, problems, questions before we go to the next piece. So it's really all about looking at what you have here and comparing the positioning of the domain and making sure that it works first. That is even a possibility first, and then to your application. All right, can I scroll up? Everybody okay? All right. So evaluating a composite trig function. So this time we're going to mix them up a little. It's not going to be cosine to cosine or sine to sine. It's going to be like cosine, in this case, cosine to tan inverse of 5/12. All right. So first, we're going to let theta be an angle within negative pi over 2 to pi over 2, whose tangent is 5/12, and that pi over 2 to pi over 2 comes from what we were talking about here. All right. So theta is going to be equal to tan inverse 5/12. And Also, just notating that if you're talking about negative pi over 2 to the power of 2, that's either quadrant 1 or quadrant 4. Let me write that a little better. Right, right, a little better. So it's either quadrant 1 or quadrant 4. Remember, that's over here. All right. So now we can bring that tan over, and that's going to be tan theta equal to 5/12. And if we apply what we established last class with the tangent being y over x, that means y is going to be 5, x is going to be 12. And so now we can find r, or, let's say if you're dealing with another problem, whatever your missing side is, that's what you would be looking for now. Once you've established the sides that you do have, you go ahead and look for the other side. Is everybody good? So we were missing r, we had x and y. So we needed r. And you see over here, we have a diagram of how that would look coming out of quadrant 1. Since we have positive 5 and positive 12 for x, for y and x. R ended up being 13. And like I said, looking at the diagram, you see where 13 would be. 12 is going to the right. That's our x. Then going up is 5. 13 is our line produced. Theta is the angle. Make sure we're okay. So don't forget what we were actually looking for. We were looking for this, and we said this is going to be equal to theta, right? So now we're going to look at finding cosine of theta. Remember, this is theta for us now, and that's what I got right here. And that's why I wrote this, just re-emphasizing SOHCAHTOA. So for cosine, I'm going to do it adjacent over hypotenuse. Adjacent is our 12, that's right beside our theta. And then hypotenuse is always the longer side, that's our r, and that's 13. And so that will be our answer, 12 over 13. All right. Questions. How to do? All right, so before we go to the next one, I just want to walk through these steps one more time. So we're going to let theta be equal to this inside right here. And then, of course, we go off of the definitions of tan inverse. Then we establish what are our sides that we do have according to what tan is. Tan is y over x. So that's why we were able to establish that that's 5 over 12. That 5 over 12 is y5, x12. Positive 5 and the positive 12 puts us in the first quadrant. That's what I was emphasizing here. Find R, because that was our missing side. It gave us 13. And then from there, we apply SOHCAHTOA for our cosine, which was sitting on the outside of our relationship. Okay. All right, so let's try it again. So this time we're letting theta be equal to the inside of here, which is sine inverse of negative 1/3. All right. Going back to your definitions or your domain of sine inverse. That's what we're leaning on this. All right. And that just tells us what quadrant we possibly could be in, you know, what quadrants we could possibly be in. Once again, if you're talking about negative power to 2, negative power to the power of 2 is either the first or fourth quadrant. And so here we have sine theta of -1/3. And sine is going to be y over r. Now we have a negative involved, but don't forget r cannot be negative. R is always positive. We talked about that last class. R is always positive. So it means that negative has to be given to the y. And so that means that's going to put us in that fourth quadrant. And that means y is going to, not y, but x is going to have to be positive. So we plug in y and r to find x. All right, so solving that out, we put 3 in for r, -1 in for y. Square both sides so we can get that square root off. 3 squared is 9. -1 squared is 1. Subtract 1 from both sides, that gives us 8. Take the square root of both sides, plus or minus square root of 8. So here we have a choice of doing plus or minus, but because of the quadrants that we have as at our availability, the only one that will fit is to use x as being positive. Theta is going to be in quadrant 4. Because remember, y was negative, so that took us down to quadrant 4. Any questions? Any questions? Now let's scroll up. All right. So now getting into our last step. Our problem was cotangent of sine inverse of -1/3. So that means you just need to find the cotangent of theta according to our diagram that we just was able to fill out. Cotangent is x over y. So x is 2 square root of 2. Y is -1. So this is what we did here and got the answer right here. Negative square root of 2 over 2. -2 square root of 2. Say it right, right? All right, questions. All right, last one. Yep, last one like this. So same process. You have sine of tan inverse of 3/4. Remember, we dealt with tan inverse already. So we already know that's going to be from negative power over 2 to power over 2. That's what theta is going to be. So we take what's on the inside. Theta is equal to that. Tangent is y over x. So that means y is 3, x is 4. And we have to find r. That ends up being 5 for us. Thanks, everybody. Okay. Rolling up. All right. So now we have sine of theta, which is going to be y over r. Y is 3, r is 5, so that will be 3/5. All right, questions on anything that I've written so far? All right, everybody good, everybody straight? Okay, so looking at Math Lab, some people need an opportunity to get caught up, so I won't keep going. Even though we could jump into 5.8, but I'll leave some room for us to not do that today and just get into a next class, because 5.8 is the last section in chapter 5. So I do want to try to give some room for getting caught up, and then for questions to be generated. So we'll pause right here. Next class we'll look to get into 5.8. Also, just to reiterate, don't forget to email me. Email me back to that with that response to that email I sent about virtual, non-virtual, virtual, face-to-face, say it like that. And then also, if you've already done so, then you're fine. Just sit back and wait for that email from me on instructions on how we will proceed moving forward. Questions, concerns, comments before we close out today? Make sure we're good. Not good, everybody stay straight. Looks like everybody's okay. All right. So, like I said, take advantage of the fact that I'm not, pushing it and jumping on 5.8 immediately, right? And let's try to get caught up and get in a position to be able to close out chapter 5 together. Haven't put a due date out there for chapter 5's content yet. So next class, we'll go ahead and establish that. It won't be the next day, so you still have some time. So it won't be anything crazy like that, but we'll put a date out there so you guys will know what, and start making your way towards that date. All right, so if you guys are good, I'm good. Have a great weekend. Be safe. Don't forget, we're going to get some snow this weekend as well. So watch out for that. And you guys have a great weekend. Take care.
Thank you. Have a great day.
You have a great
Thank
day.
you very much.
Thank you. Take care.